Hello friends, I am Abhishek Narolia. I am a software working professional. I am having 17 years plus experience in the software development with the modern C++, legacy C++, as well as the C. Today we are going to implement a vector class. The vector that is already a member of STL, that is Standard Template Library. So we are going to implement it at our own so that we will get to know how it works internally. It has many functionality. So this is the first lecture on this vector implementation. So today we will be implementing, you can see the list. So all these things we will be implementing: default constructor parameterized, then copy constructor and assignment operator, then move constructor and move assignment operator, then reserve, pushback, capacity, size, and subscript operator. These are the important ones basically. I don't say others are not important. They are also important. But in the first phase, we are going to implement all these things. And in the next lecture, we will implement other things as well. For example, we need for begin and end, we will require to implement our own iterator class as well. So that we will be doing. So I have split it all entire implementation of vector in 3 lectures basically. So in the first lecture, we are going to implement these things which is on your screen as of now. And the good thing, you might have seen implementation of own vector, and probably that is with the raw pointer only. The implementation that we are going to do today, I am going to use smart pointer in that instead of raw pointer, and we are going to use unique PTR for it. And not only our concentration is to implement vector class, also we will concentrate to put the best C++ code. Best means the code that should provide a strong exception guarantee, and the coding standard should be the production level or professional level coding standard. So all things we will keep in mind, and at the same time we will write low latency code, or we can say more efficient code or better efficient code. So let's not waste any time. Let's start implementation. So the good practice in C++, whenever we introduce a new class, and if it doesn't fit any existing namespace, then we should create a new namespace. So basically, every class should be a part of namespace. So let's create our own namespace. Since we are implementing our own vector class, so name of namespace is own, and class is vector class. And since we want this class to work with the different data types, so that it should be a template class. Okay. Whenever we write a C++ class, it's always a good practice to provide public members first and then private members. So now, first of all, what data members we will be having in our vector? So since it is a vector, it will be having a size, and I am not going to take size as type of integer because int could have a negative value and size cannot have a negative value. It should be always positive, either 0 or greater than 0. So I am going to use size underscore t. And as per the coding standard, since this is data member of the class, so the name starts with underscore. The second member will be the capacity of the vector. What is the capacity and what is the size? So capacity is the memory, dynamic memory, which is allocated to store n number of elements. So capacity is n. But if m number of not m, x number of elements are inserted in the vector, then size is x. So size is x, but the capacity is n, then capacity is n. And now we require a pointer which is going to point to the dynamic memory. And as I already told, we are going to use unique PTR. So if we are using unique PTR, then we need not to worry about deletion of the memory. And very important point, this unique PTR is going to point to an array. So it has to be an array. So don't forget to mention array over here. Okay, fine. So these are our data members. Now, default constructor and parameterized constructor. So we will be writing one constructor where we will provide default value so that the default, it will work as a default constructor as well as parameterized constructor. So let's write it quickly. First parameter will be size. And default value of size will be 0. As a good coding practice, we always check if we can make parameter const. Size is not going to modify inside the constructor. So yes, it has to be const. And can we have this reference? Of course. So it should be const reference. What should be the next one? Next parameter. Next parameter is value. It should also be const because it is not going to be modified in the constructor. So const t reference and I give a default value. Okay. So now we write initialization list of the constructor. We set the value. Size is whatever size we have got. Now, what is the capacity? So here, it's fully up to us if you want to create some capacity or if you want to create memory even though size is 0. So let's have some default value. Let's say unsigned short and depth capacity. And let's consider the capacity 5. So if size is 0, then we will use default capacity. Otherwise, whatever is the size, we will allocate that memory only, and capacity will equal to size if size is non-zero. So if size is 0, then default capacity. Else, whatever value size is having. Fine. Now we need to allocate memory. And how much memory? Whatever value capacity is having. So that much memory we need to allocate. We are using Mac Unique, and I would suggest always use Mac Unique and Mac Shared in case of shared pointer. These are much better option. These are basically more exception safe, I would say, and Mac Share even more efficient. But Mac Unique is definitely provide more exception safety. I will discuss about these two in detail in my another lecture. So today only single line. These are Make Unique is more exception safe. So don't forget to mention array. Okay. So we have created memory. Sorry, this is underscore PTR. Okay. Now, if size is non-zero, then definitely some value will be there. So we need to assign that value. So let's write a for loop quickly. One more suggestion. Usually C programmers write I++. So let's start habit using ++I, pre-increment operator. In C++, uh, in case of user-defined data type, the implementation of a pre-increment operator is more efficient than the post-increment operator. So let's change the habit. If you have any habit to write I++, let's make it ++I, so that everywhere you will use pre-increment operator. If logically post increment is required, then definitely we will have to use post increment. But here I can use pre increment as well. So let's go with the pre increment. Okay. So let me initialize ptr equals to value. Now, as I promised, we are going to write a very professional C++ code. So let's see. In this constructor, we have put the implementation in such a way it is not going to throw any exception. So constructor will not throw any exception. We will give this guarantee by writing this no except, and this constructor has to be explicit. Why explicit? Because we do not want any implicit call to the constructor of our class in case of type conversion. So that's why we have put explicit. Let me build the code. If any compilation error, let's fix it. So value identifier is not found. Okay, so oh, very nice. Value we have not defined itself. Okay, so far so good. Now we are done with default as well as parameterized constructor, two in one. Now what is next? Destructor. If we talk about destructor, since we are using smart pointer over here, so we do not require to handle memory deallocation. But just sake of completeness, I just provide its body, but empty body. Vector empty. Okay. Again, very important point. Destructor must not throw any exception at all. So we should give the guarantee as well. No exception. Yeah. What is next? Next is copy constructor. We will implement move later. First copy constructor and then copy assignment operator. And then we will implement move operations. So let's implement copy constructor. What should be the parameter type? Const vector reference. That is the parameter for copy constructor. Source. What do we expect in the copy constructor? It should copy, but it should copy deep, not the shallow copy. So the pointer, we will not copy values of pointer. We will copy values which are pointed by pointers. And both the pointers, source pointer as well as the pointer in the object this means which is under creation. Both pointers will be pointing to different memory location, but elements will be same. So we will perform deep copy. So let's use initialization list for it. First of all, size, source size, then capacity, source capacity, okay. Then we are not going to copy PTR value. Instead of that, we will allocate a new memory. PTR, we have make PTR. Don't forget to put array. and the capacity. And here what we will do, we will assign, we will copy values one by one. So size and ptri should be source of I. Okay, so now you can see this. I have used subscript operator directly on the vector object. Since we are going to implement subscript operator, so it will work. That's why I am using subscript operator over here. So let me build and check for any compilation error. Okay, all good so far. So we are done with the copy constructor. Are we forgetting anything? Yes. This copy constructor will not throw any exception. No exception. Done. Let's move to the assignment operator implementation. Okay. So what should be return type and what should be the parameter type? Return type should be vector reference and parameter should be same as copy constructor. So okay. Now first of all, whenever we implement assignment operator, the first check that we need to perform is the self assignment check. So we should check whether this pointer and the source pointer is same. Pointer, that means address of source, and this is same. If that is same, means we are trying to assign same object, and in that case we should not perform any assignment operation. If both are different, then only we will perform assignment operation. So let's put a check. If this not equals to ampersand source, then only we will perform assignment operations, else not. And then at the end we will return the current object. So start this. Now, what is expected with the assignment operator? Just assume that first of all, source is object. So let's say the PTR in the source is pointing to a memory location 100, and at that location there are 5 values in the vector 1, 2, 3, 4, 5. At the same time, we have this object that is also there. That is also having PTR. So let's say it is pointing to a memory address 200 and it has some value 5, 6, 7, 8, 9, whatever. Now, the expectation with this operation is logically source is having 5 values, even though pointer is pointing to the 100, but values are 1, 2, 3, 4, 5. So after this operation, the pointer of this means underscore PTR inside this object should be pointing to a memory location that will be having elements 1, 2, 3, 4, 5. This memory address will be different. So source will be having memory address 100 and this will be memory address something say 500, but elements will be same like source 1, 2, 3, 4, 5. And since this is currently this underscore PTR is pointing to a memory location 200 where some values are there 5, 6, 7, 8 right now. So that memory should be deleted. So expectation is we should perform a deep copy basically, and whatever PTR you are currently having, you should delete that memory as well. That this is expected in the assignment operator. And using copy and swap concept make it very easy and exception safe. So just see, only 2 lines of code. I create a temporary object and basically I am creating a copy of source. Copy of source. And then what I am doing, then I would say swap, swap with temp. Now see how this is going to work. But before that, I need to implement swap. So, right, this is, I am calling on my pointer only, this pointer. So I need to implement swap. And since this is internal to the class only, so it should be a private. So let me implement swap. And what swap will do? It will just swap each and every data member. That's it. Return type should be void. Swap type will be vector reference source. I am going to use std swap for this, for each and every data member. Okay, so let's understand now how this will work. So source is pointing to a memory location 100, which has element 1, 2, 3, 4, 5. I have created object of vector using copy constructor. So temp, PTR of temp will be pointing to, let's say, memory address 200, and it will be having the same element that source is having 1, 2, 3, 4, and 5. Source is pointing to memory address 100, temp is pointing to memory address 200. And this is currently pointing to a memory address 300 that has some other elements. Now, we call swap. So whatever temp is having will be swapped with this. So temp is having memory location 200. So now this will be having memory location 200. And this had memory location 300. Now it is with the temp. So memory location values are swapped. After this curly braces, this temporary object, temp object, will go out of scope and its destructor will be called. And since this temp object already has a unique PTR, so that unique PTR destructor will also be called, and in that unique PTR destructor, the memory address 300, that dynamic memory will be deleted. So that's it. So only 2 lines of code doing all the things for us. Fine. If you have any question, you can put in the comment section. I can clarify. Okay. So let's move on. Move on to the move constructor now. So now move constructor. So first of all, this move concept is introduced after C++ 11 only. So let's implement it. What should be the type of parameter? It is R value reference. So whenever any constructor is called with R value reference, its move constructor will be called. So we will see how move constructor will be called and all that we will see. Since this is constructor, so it should not throw any exception. Okay. So now we want to move all the values from source object to the current object which is under construction. So I will do it in initialization list of the constructor only. So size, I am using std move. Okay, now let's move other data members as well. Capacity and PTR. Okay, so first thing I would like to discuss on the STD move. First of all, STD move doesn't move anything. Please do remember, STD move doesn't move anything. It only does one work, and that is typecasting from L value reference to R value reference. It does only and only this thing. It doesn't move anything. Then how things will be moved, that we will see. We are going to move values in our constructor. We are putting the logic. STD move is not doing anything. It is just helping us to convert L value reference into R value reference. In case of user defined data type, it will help us to call move constructor basically. And inside the move constructor, we will write logic to reset the value. Now, if you see what this statement will do, let's say source size has a value 5. After execution of this statement, this size underscore size from this object will have value 5, but at the same time source size will also have value 5. It will not reset to 0 automatically by STD move. Because it simply convert L value reference to R value reference. It doesn't change any value of the parameter. If capacity is 10 in the source, it will be copied to this capacity, but here also the value 10 will remain. Here case little bit different. Since underscore PTR is a unique PTR. So unique PTR has its own move constructor. So once we call std move, what it will do? It will convert this L value into R value so that the move constructor of unique PTR will be called. And inside the move constructor of unique PTR, logic implemented in such a way from the source, it copies the pointer value to the object which is under creation, and then it will reset the value of source. So after execution of this statement, underscore PTR, if source has PTR which is pointing to 100, then this underscore PTR will have the same value 100, but inside the source it will reset to null PTR. And this is not done by std move, this is done by the move constructor of the unique PTR. So do remember, std move doesn't move anything, it only typecast L value reference to R value reference. So here we need to set them explicitly, right, to 0, because we want that if this is our class, right, this is our class, this is vector class, so we want it, so we will make them explicitly 0. So size is 0, capacity is 0 for move constructor only. Yes, so this is our move constructor. Let me compile if any error, let's see. Okay, so far so good. Now after move constructor, let's go for the move assignment operator. So move assignment operator, what will be parameter and what should be return type? Return type will be similar to the copy assignment operator, that is vector reference, and parameter is like move constructor. And yes, of course, we want move assignment operator also exception safe. Now implementation of move assignment operator is as good as copy assignment operator with one modification. I'll tell you the modification. So first of all, we need to check self assignment. Here, what we did previously, we created a copy. We called a copy constructor from copy assignment operator. This is move assignment operator. So what we need to call? We need to call move constructor. So one change we need to do. We need to convert L value reference to R value reference. So now move constructor will be called. So this particular code will call move constructor. So now what will happen? First of all, what is expected with move assignment operator? If source is pointing to a memory address 100 and this is pointing to a memory address 200, so after move assignment operator, this should be pointing to memory address 100 like source, but source should be reset to null PTR. It should not point to anywhere now. As well as its size and its capacity should also be 0. And this which was pointing to a memory address 200 previously, that memory should be deleted. So let's see if the same thing is happening here or not. So after this move operation, we implemented our move only. So pointer will be moved, pointer will be null PTR, size will be moved here, and explicitly we are making size and capacity in the source 0. So yes, after this move operation, line number 75, if source is having PTR value 100, size is 5, capacity is 10. Then after this move operation, temp will have PTR value 100, size 5 and capacity 10. And source will have null 0, 0. So source object has everything 0. Now, if we say swap temp. So temp is pointing to 100 as of now. This is pointing to memory 200. Swap means temp will be pointing to memory 200 now. And this will be having memory 100. Size and capacity will also be swapped. We implemented our swap function. And once temp object goes out of scope, it will delete the memory which is at memory address 200. That's all. This is what is expected from move assignment operator. So let me compile the code. Okay, so far so good. So what is next? Let's see. So we are done up to here. Reserve pushback capacity. Okay. Okay, so reserve. So first of all, before writing reserve, just quickly talk about the reserve of the STD vector. So what we do, so we are trying to implement in the same way. That's why just in 2 minutes we will be discussing about vector. So let's say STD vector I create and int vector I create vec. Default constructor was called. So size was 0 and capacity was 0. If we see implementation of vector on Windows platform, then the default capacity is 0 only. So it doesn't create like us. Unlike us, we have default capacity 5. So even size is 0, we allocate memory for 5 elements, but here it doesn't. So, but after that, if we call vector dot reserve, that means we are asking vector to reserve a memory, let's say 100 elements. So it will allocate memory for 100 elements now. So reserve will allocate memory whatever value we pass to it. But there is one thing. We do some operations fine, and later we think that, oh, we do not require 100 elements. I think its value should be only 40 or 50, say. So I again call vector dot reserve, let's say 40. Now reserve will not change, will not do anything. It will check if the capacity After calling reserve, capacity will be 100 only. It will check if capacity is greater than this or not. Since capacity is greater than this, so it won't do anything. It won't deallocate the memory basically. So reserve will allocate the memory and it will increase the memory only. It will not reduce the memory. So we will implement in that way only. And uh, if we do some pushback operation, let's say if we have put inside vector some 2 3 elements, and then we call reserve this time, let's say with 150, then yes, it will reallocate the memory for 150, and whatever element we are having in the vector, it will copy to the new location as well. So our reserve should be doing all these things. So let's implement this. Okay. So return type should be void, and parameter should be number of elements that we want to allocate. Const size should be reference. Number of elements. Okay. So the first check we require, we already discussed when it will not do anything. If capacity is already greater than or equal to with the number of elements, then we do not require anything. So let's have this check. If if capacity greater than or equal to, even equal to, we should not make any change. Then simply return. Don't do anything. If this is not the case, then yes, we need to reallocate memory. So now here we need to put the logic to reallocate. But uh, when we will implement pushback, then also we will require logic to reallocate the memory. So instead of making same code at two different places, means duplicate code in our class, let's make it at one place only. So let's implement a reallocate function that will do the reallocation. And since this is going to be called from R code only, so it should be private. So let's implement reallocate. What should be parameter? Parameter should be the same, I think. Yeah. And this will not throw any exception. Okay. So how do we perform reallocation? What should we do? First of all, we should create a temporary object. We should allocate the memory for number of elements that we are having over here. Then we should copy all the elements from the current object's PTR, and then we will swap temp PTR with this PTR. This will perform reallocation. So let me write the code, and then we will understand it. So let's create a temporary unique PTR. Unique PTR of type TRA. Let's say temp. Make unique TRA. for number of elements. Yeah. So now we have memory, and now just we need to copy elements from this object to this temp memory. This PTR to the temp memory. So let me write quickly the for loop, or let me copy. We have okay. So we need to copy in temp. So temp from PTR of current object. In that way, we have copied all the values to a new memory location, and it has larger number of memory. Okay. Now we have copied. So now everything that we require is available in the temp. So now swap temp with the underscore PTR, which are unique pointers. And unique pointer has a method that is swap. It will perform swap. So let's call that. Sorry. Dot swap. Swap with temp. So we are done. But we have changed one thing. Memory capacity has been changed. So here we need to update capacity with the new value. And new value is number of elements. So yes, reallocate will perform reallocation. It will make capacity to the current one as well, whatever is the memory size, not the number of elements. So okay, now we will call this reallocate. That's it, from reserve. So we will call so it will allocate the memory. Now we have seen reallocate, we may it in such a way so that it will not throw exception, and we have make it no except. So since it is no except, reserve will also no except. Let me compile the code and check if any compilation error. So far so good. Okay, so reserve is done. Now we need to implement pushback. Now first understand what pushback of std vector is doing. First let's write its signature. So what it will take? It will take t reference. So const t reference, and it's a value that we need to push at the end of the vector as a last element in the vector. So first of all, what pushback is doing in the std vector? First, it will check if there is enough capacity to push the element. Then it will simply add the element to the array and increase the size by 1. If capacity is not enough, then it need to allocate the new memory so that enough capacity should be there and new element can be inserted into the array. So if require, it will reallocate memory. If doesn't require, then it will simply add element in the array at the end. So let's implement in that way. So first of all, when no reallocation is required, or when allocation is required, let's say if size, if size either greater than or equal to with the capacity, then certainly we will require reallocation. This greater than I have just put for a safety. If I write size equal to capacity, then also it should be fine. So if size is equal to capacity means there is no capacity at all. Now we need to reallocate the memory. So to reallocate the memory, we already implemented reallocated function. So let's call it reallocate. But how much memory? First of all, whatever is the size, it has to be there. And how much? If you remember, in our default or parameterized constructor, we considered default capacity. So here, let's consider that size plus default capacity. So let's say if size is 10, then memory 10 plus 5, 15 or 15 elements, it will be reallocated. And all these 10 members will be copied to the new memory location. So yeah, now it is reallocated. So let's add the element. At what index? Size. So let's add it value. Okay. And size is increased. So plus size by 1. So this is implementation of pushback. And pushback will not throw exception. So what is next? Capacity, size and operator subscript. So capacity is simple, just we need to provide capacity. So it will be a read-only function. So capacity is size underscore t. So return will be size underscore t. Capacity. No parameter. It will return capacity. Since this is only read-only function, so it has to be const and it is not throwing any exception in any case. So no except. Like size, like capacity, we can have size. Okay, let me compile the code. Okay, so far so good. So last but not the least, that is subscript operator. Subscript operator, what it should return? It should return dereference. And what should be the parameter? Parameter should be index. So it should be index. And what it should do? It should return the element. That is underscore ptr index. Let me build the solution again. Okay. So we have implemented all the things which are in our list. Now let's test them one by one. So I have, yeah, one by one. So what we did, Oh, yeah. So we need to provide, yeah, a couple of more functions. First of all, let's provide a print function that will print all the elements in the array so that we can test our code. So I write here print function. It will be called on object of vector, so no parameter is required. It will print it will print elements in the for loop. So let me copy for loop. Where is my for loop? Yeah. Hmm. So underscore ptr I, and let's put a space after each and every element, and once all elements are printed, let's put new line character. Okay, so now we will print this. So we are okay for elements printing, and if you want to print size and capacity everything, then let's write one utility function so that it can print everything. So we write utility function over here. And we want to print statistics of all of vector, all the statistics of all the vector, basically. So this way. Inside this, we will print capacity, we will print size, as well as we will print elements. And let's make it template function. It will take vector of type T. uh, Reference, and let's say that. Okay. Now here we will simply print first of all capacity, after that, okay. Then it will print size of the vector, okay, and then it should print elements. So okay, let's say new line, and then we will print elements. So for elements we have already print function. That's one. Yeah, we are done. So this is just utility function to print all the statistics so that we can verify whatever logic we have written whether it is working or not. So here, first of all, we have created a vector. So if you remember, we created a vector with the default value. So size is 0. Size is 0. In case of 0 size, we create vector with the capacity 5. So let's print there as well. So the first print should be size should be 0, capacity should be 5, and elements none elements. In second case, we have called reserve first. So here size should be 0 since we have not added element yet. But capacity should change to 10 and no elements. So let's run. Yeah, here we can see capacity is 5, size is 0, capacity is 10, size is 0. So we have tested reserved, we have tested default constructor, So both logic are working fine. Here I should give one space. Okay. Now the next one. Next one, let's add some elements. So here we have added two elements, and then again we are printing statistics. So in the previous print, capacity was 10, size was 0, and there were no elements. So now there should be two elements, 1 and 2 should be printing, and size should be 2 since there are two elements. So capacity remains same, 10, size is 2, and these are the elements. So pushback is working fine. Let's check copy. So what we are doing over here, vect object is already there. It has two elements now, 1 and 2, capacity 10, size is 2. We have copied it into vect1 and we have again printed vect1 and vect. So both will be having same value, size equals to 2, capacity equals to 10, and elements 1 and 2. Okay, yeah, it was expected. So now no matching overloaded function found, and here, okay. So we have implemented subscript operator, and that operator is not called by this. Why? If you see type of source, that is const, and the operator that we have implemented, we have implemented, where it is, okay, here it is for non-const. So we have to implement for const. One more version we need to provide for subscript operator, and it has to return const t reference, and function has to be const. Okay. So not make pair, this should be make unique. Sorry. Okay. Now let's see. Yes, copy constructor is working fine. Same capacity, same size, same elements. So copy constructor is also working fine. Then let's test for move constructor. Okay, so what is expected? Now vect is moved from vect is moved to vect2, and then we are printing vect2 and vect. So vect should print size 0, capacity 0, and no element. And whatever vect is having right now, we can see in this print statement. So vect2 will have the same value. So move constructor, yes, the same value, this value, this is the vect value. It is now in vect2, and vect1 is reset. No element, capacity 0, size is 0. So move constructor logic is working fine. Now copy assignment functionality, let's test. So we are copying vect to vect1 to vect, and both should have the same value. Copy assignment, capacity 10, size 2, capacity 10, size 2, element 1, 2, 1, 2. Yes, logic is working fine. The last one, move assignment. Now we are explicitly calling this move assignment operator over here. We are from vect2 to vect. So vect2 should be empty, and vect should have the value what vect2 was having previously. Yes, vec2 is empty and vect is having the value what it has previously. So this is all about vector implementation for today only. As I already discussed, the rest of the things we'll also implement. We can't go in one sit because it's a huge implementation. So we will try to complete this in 3 or 4 sessions basically. So for today, this should be enough. If you have any query, so please add in the comment section. If you have any suggestion, please add, give your honest feedback. And if you like, then please like the video and subscribe to my channel, because I'm going to add much more things. For example, implementation of unique PTR, implementation of shared PTR, implementation of thread pools. So every week I will try to put 1 or 2 sessions. So be subscribed. So thanks everyone.